close your eyes. Imagine a darkness so complete that the concept of seeing doesn't even exist yet. Not the darkness of a room with the lights off, not the darkness of deep ocean, not even the darkness of a cave sealed for 1,000 years. The darkness of absolutely nothing. No stars, no planets, no galaxies, no light of any kind, just hydrogen, drifting, silently, in all directions, forever, for 200 million years. This is the story the universe doesn't tell about itself. Scientists call it the cosmic dark ages, and it's perhaps the most important chapter in the history of everything that has ever existed, including you. But almost nobody talks about it, because there was literally nothing to see. Let's go back. 380,000 years after the Big Bang, something remarkable happened. The universe had been expanding and cooling since its violent birth, and for the first time, the temperature dropped just enough for electrons to slow down, to stop screaming through space, and to finally, for the first time in existence, attach themselves to protons. Atoms formed, and in that moment, a blinding flash of light was released across the entire universe simultaneously. That light still exists today. We call it the cosmic microwave background. It's the oldest light in the observable universe, a faint afterglow of creation itself, still traveling in every direction, even now, even as you listen to this. If you tuned an old analog television between channels, a tiny fraction of that static, that's the echo of the Big Bang reaching your living room. But then something strange happened. The light faded. As the universe expanded, that primordial glow stretched and cooled into invisible infrared radiation. The universe went dark. And it stayed dark. For 200 million years, there was not a single source of light anywhere in the observable universe. If you could somehow transport yourself back to this era and float in space, you would see absolutely nothing in any direction. Zero. Complete, total, absolute darkness. No warmth, no sound, no reference point. Just you, suspended in an infinite black void, surrounded by invisible clouds of hydrogen gas drifting past you in total silence. Now let's talk about what was actually happening in that darkness. Because here's what's incredible. Gravity never stopped working. While the universe sat in total darkness for 200 million years, gravity was doing something extraordinary, silently, invisibly, patiently. It was pulling those vast clouds of hydrogen, the ones you couldn't see, drifting through that perfect void. They weren't evenly distributed. Some regions were ever so slightly denser than others, just fractionally more atoms per cubic meter. And gravity noticed. Those denser regions pulled slightly harder, drew in slightly more hydrogen, became slightly denser still, which pulled slightly harder, drew in slightly more. For 200 million years, this process continued, invisible, silent, unstoppable. Gravity was building something. Then, approximately 200 million years after the Big Bang, give or take a few million years, a threshold was crossed. Deep inside one of those collapsing hydrogen clouds, the pressure became so extreme, the temperature so unimaginably intense, roughly 10 million degrees Celsius, that something happened which had never happened before in the history of the universe. Hydrogen atoms began to fuse. Protons slammed into each other with enough force to overcome the electromagnetic repulsion that keeps them apart under normal conditions. They merged. They became helium. And in that fusion reaction, energy was released. Light was born. For the first time in 200 million years, in the entire history of the universe up to that point, there was a source of light. The first star had ignited, and these first stars were nothing like anything that exists in the universe today. Scientists call them population 3 stars, and they were monsters. We believe some of them were 300 times more massive than our sun. They burned at temperatures 10 times hotter. They were so luminous, so impossibly bright, that a single one of them could be detected across billions of light years. But they lived fast, and they died young. Because the more massive a star, the faster it burns through its fuel. These giants, these first lights in the universe, exhausted their hydrogen in just a few million years. A few million years. Our sun has been burning for 4.5 billion years and has another 5 billion to go. These first stars burned through their entire lives in the time it takes Earth's continents to drift a few hundred kilometers. And when they died, they exploded in supernovas of almost incomprehensible violence. Explosions so powerful that for a brief moment, a single dying star could outshine every other source of light in the observable universe combined. But here's why those explosions matter more than almost anything else that has ever happened. Inside those dying stars, in the last moments of their lives, the extreme pressures and temperatures were doing something that had never been done before in the universe. They were creating new elements. Hydrogen fuses into helium, helium fuses into carbon, carbon into oxygen, oxygen into silicon, silicon into iron. And when those stars exploded, they scattered those elements across the cosmos. For the first time in history, the universe contained carbon, oxygen, iron, nitrogen, all the raw materials for everything that would follow. As more and more of these first stars ignited and died across the universe, their radiation began doing something else remarkable. It reionized the hydrogen gas between them, stripped electrons away from hydrogen atoms. Slowly, over hundreds of millions of years, the fog that had filled the cosmic dark ages began to lift. The universe became transparent. Light could finally travel freely across all of space. The cosmic dark ages were over, and the universe we recognize today, full of galaxies, stars, planets, and eventually life, had truly begun. Here's what hits different when you really sit with this. Every single atom in your body has a history that stretches back to those first stars. The carbon in your DNA, the oxygen in your lungs right now, the iron carrying oxygen through your bloodstream at this very moment. All of it was forged inside a star that ignited in the darkness, burned for a few million years, and then exploded, scattering its contents across space. Contents that eventually became part of a gas cloud that collapsed into our solar system. That became rocks. That became oceans. That became single-celled organisms. That became, after billions of years of evolution, you. Sitting here, listening to a story about the darkness that made you possible. The universe spent 200 million years in complete darkness, waiting, building, preparing, and then it turned on. And everything that has ever existed, every civilization ever built, every thought ever thought, every love ever felt, all of it traces back to that single moment of light in the void. Which makes you wonder, what's being built right now, in the darkness that we can't see? What's being assembled silently in the places we haven't looked yet? What comes next? If this changed the way you see the universe, even slightly, subscribe. Because next time, we're going somewhere even stranger, to the very edge of what exists. And what's waiting there?